All right. Okay. Right. Good evening, all. First, can you confirm whether I'm audible? What about my audio? Is it clear? And about the video, is it clear, students? Yeah, students. What about the audio? I'm audible, right? Tell me. How are you live chatted that? Whether you are hearing me properly? Clear. All right. Clear. Okay. Right. Thank you. If there's anyone who don't have the paper, first I'll put that to the chat. මම live chat එකේ දාන්නම් මේ pin කරලා message එකක්. From that link you can download the paper if you don't have the paper. Right? So give me 2 minutes. If there's anyone who don't have the paper, let me put the link. All right. All right. Okay. I have put a message to the live chat where you can see a pinned message. So you can visit that link and download the paper if you don't have the paper. Right? Okay. Listen, good evening, good afternoon, sorry, good evening again. And today, the plan of the discussion is this. This is a past paper discussion, and we'll be starting with 2019 A-level past paper, right? And today, you are going to have the part 1 of that paper. So we'll be stick to the MCQ one, but from that link, you can download the full paper, right? So I have sent you the full paper. And starting with 2019, my plan is to carry this session forward for all coming 6 years, including 2019. There are 6 years up to 2024. So my plan is to carry this session forward to discuss all past paper questions starting from past papers starting from 2019, right? So today we will be starting off with 2019 part one. Part one, we are in the MCQ today, and then on other day we will be having part two, and 2020, 21, 22, 23, 24 likewise up to the latest paper. I'll be extending this discussion as you can take the maximum advantage, and most probably this will be happening on Wednesdays, right? So for now the fixed time is Wednesdays, and all the sessions will be conducted as YouTube live sessions, right? All right, so since you are joined already, so we'll start, and I hope you are ready with the paper and you have downloaded the paper, and you are ready for the discussion, right? Okay, let's see. Okay, go to question one. Go to question one. Which of the following is not a fundamental unit? So you know we have 7 fundamental units. We have 7 fundamental units and 3 dimensions. This is about fundamental units. We have 7 fundamental units. Meters is a fundamental unit. Joules is not a fundamental unit. Very straightforward, right? And candelas is a fundamental unit. Kelvin is a fundamental unit, and moles is a fundamental unit, right? Now, if I explain further, meters is the fundamental unit of length, right? Joules is not a fundamental unit. That is the SI unit of energy or work, right? SI unit of energy or work. That is not a fundamental. Candelas is the fundamental unit of luminous intensity, and kelvins is the fundamental unit of thermodynamic temperature, and moles is the fundamental unit of amount of substance, right? So therefore joules is not a fundamental unit. For first one, answer 2. For first one, I'll be mentioning all answers here. Is it visible? Yeah, here. For first one, answer 2. Right. For first one, answer 2. That is very straightforward from theories. Right. Second one, the dimensions of the gravitational constant G are given by dimensions of gravitational constant. Right. You have to know the equation, right? You have to know the equation. So we know F equals gravitational force equals G times M1 M2 over R square, right? M1 M2 are masses. R is the distance between two centers of masses. Distance between two centers of masses. F is gravitational force. Gravitational force is a force, right? Now, if you are to determine dimensions, dimensions of F will be dimensions of G times dimensions of these two over this, right? Okay, then substitute these values. Dimensions of force is MLT minus 2, and we need dimensions of G, right? M1, M2 are masses. So dimension of that product is M squared, and R is a distance. Dimension is L, so that is L squared. Simplify this. Dimensions of G. Dimensions of G is from M squared to M, which means M minus M remains, right? M to the power 1 is here, M squared is here. So which means M minus 1 remains. And cross multiply this. So L cube comes and T minus 2, right? So M minus 1, L cube, T minus 2. L cube, T minus 2. L cube, M minus 1, T minus 2. Answer is 4, 4. Right? For 2, answer 4. For 2, answer 4. Three. 3. When a bipolar junction transistor operates in a saturation mode, a further increase in base current will. That is again straight from theories. Again, very straight from theories. Right? When it comes to bipolar transistors, we know the variation between IC and VC. So we know the variation between IC and VC. Right? So it is like this. The variation goes like this. Right? So in the saturation region, this is saturation. This is saturation. So in the saturation, IC is a constant. In the saturation, IC, collector current is a constant. See, IC is constant. IC is constant. So therefore, by changing anything, IC cannot be changed. IC cannot be changed. So what is asked? Students, is my video lagging? Right? Students, is my video lagging? Or is it okay now? Can you quickly give me a response? Is my video lagging? What about the video today? Can anyone quickly confirm whether it's lagging or it's fine? I'll check from my end as well. It's not much clear. Let me check. Give me 2 minutes. Now okay. Let me check. I think now it will be fine. I think now it will be fine. Let's see. Okay. Right. So the question is, when a bipolar junction transistor operates in saturation mode, a further increase in base current will. First one is turn on the transistor. No, because transistor is already on. Now, in saturation region, saturation means transistor is already on. Saturation means transistor is on. Transistor is already on. Transistor is off only in the cutoff region, right? So we know 3 regions are there for a bipolar transistor as cutoff region, active region, and saturated region, right? Only in cutoff region, the transistor is off. Now transistor is already on, right? It's on. Turn off transistor, no. Increase the collector current, no, because IC, collector current is a constant. So therefore, not change the collector current. No, collector current, right? Answer 5. No change in the collector current because IC is a constant. To this graph, right? For 3, answer 5. For 3, answer 5. IC is a constant according to this graph. IC is a constant, right? 4. According to the evidence found in particle physics, matter is composed of. That's a very straightforward and a popular question. So we know it composed of 6 quarks and 6 leptons, right? So if anyone don't know what 6 quarks are, these are the 6 quarks we have, right? We have 6 quarks as up, down, top, bottom, charm, strange. 6 quarks. These altogether 6 quarks, right? And 6 leptons are electron, muon, tau, right? And this is electron, neutrino, muon, neutrino, electron, neutrino, muon, neutrino, and tau, neutrino, right? These are the 6 leptons, right? So therefore, according to quantum physics, according to particle physics, we have 6 quarks and 6 leptons, right? So answer is 5. 6 quarks and 6 leptons. Answer 5. For 4, answer 5. Right? 5. The variation of the gravitational potential V due to a point mass with distance r is best represented by, right? Gravitational potential, you have to know the equation first, right? So before thinking of the graph, before plotting the graph, you have to know the equation, right? What is the equation of gravitational potential? Gravitational potential V can be written as minus GMOR, right? Gravitational potential is minus GMOR. If x and y are, see now if I identify these quantities, now this is acting as y in the graph and r is as x, right? And whatever this is here is a constant. So let's say m. So this is like y equals minus m of x. This is a standard curve. This is an inverse curve. This is an inverse standard curve, right? So we have 2 shapes for inverse curves. We have only 2 shapes for inverse curves, right? Y and x. This is y equals y equals 1 over x. This is y equals 1 over x, right? And this is also y equals 1 over x. And this is y equals minus 1 over x. This is y equals minus 1 over x. So this is also y equals minus 1 over x, right? Now this is also having the same shape. Y equals minus 1 over x shape. So answer is here. Answer 2. Answer 2. For 5, answer 2. For 5, answer 2. For 5, answer 2. If there's anyone, it's blurry now. No, I checked my connection from my end. The thing is, it's kind of raining here. So that's why I wanted to see whether there's a connection issue from my side. But now it says it's fine. Yeah, now from my end, the connection is fine. And I checked the live from one of my other devices as well. Now fine, eh? Yeah. So that's why I asked, because now some sort of a raining is here. Sometimes with the rain, there will be like losses in the strength of signals. That's why. Now okay. Ne? All right. Okay. All right. If there's anyone who don't know how to plot graphs, I conducted a separate live session on plotting graphs for A-level physics. So you can find that video in my channel. So you can go there and refer that video. You can watch that video and try these things, because when it comes to a MCQ paper, you are getting around 10 graphs, right? From 50 MCQs, 10 graphs will be there out of 50, right? So therefore, it's a must needed skill. It's a must needed skill, must have a skill when you are going to the exam, right? Because 10 graphs means that is 10 marks in the MCQ paper, right? That's a huge amount. That's a very huge amount. right? So therefore, if you don't know how to plot graphs, please go and watch that graph plotting video I have streamed live. Yeah, I think in the last month. Yeah. Oh, okay, right. Yeah. I'm also checking my video. Yeah, now it's okay, right? Okay, next one. 6. 6. Which of the following statements is incorrect regarding thermometry? Which of the following statement is incorrect regarding thermometry? Okay, let's see. There must be a measurable physical quantity that varies with temperature. Yes, definitely yes. That is called thermometric property. And the thermometric substance, there must be a measurable physical quantity, right? So that's a thermometric property. And 2, mercury glass thermometer consists of thin wall glass tubes. Yeah, that is correct. Thin wall glass tubes. Because the reason is uh, to increase heat conduction through the glass tubes. 3. By using a mercury glass thermometer with a large mercury bulb, the range of measurements can be increased. No. Now, with that, sensitivity might increase because when comes to, look at here, 6. When comes to mercury in glass thermometers, it works from the volume expansion of mercury. So delta V equals V1 gamma theta. Delta V can be written as A times delta H V1 gamma theta. Sensitivity of the thermometer is the rise of the mercury column per unit temperature, right? Then that is delta H over theta. That is delta H over theta. It can be written as V1 gamma over A. V1 gamma over A, right? Now what happens if V1 increases is, see, if V1 increases, sensitivity increases. This is sensitivity, right? So if V1 increases, sensitivity increases. No range increase, no increase in the range because range of a thermometer is with respect to its boiling points and melting points, right? Because range cannot be increased by increasing volume, right? Now, as an example, let's assume the boiling point of mercury is at 150, right? So it cannot be used to measure any temperatures which are beyond 150 because at the boiling point it will boil, right? So if that's a melting point, it will melt. So therefore, for the range, what matters is the state changes, whether there's a boiling point or a melting point in between. So by changing volume, we can't change the what range. So therefore, incorrect one is 3. Let's check 4 and 5 as well. 2 different types of thermometers may give slightly different readings at a same temperature as all thermometric properties are not equally sensitive. That is correct. That is correct. Right? Because different thermometric properties are having different sensitivities, right? That is correct. As an example, gases are very sensitive, right? The thermometers which use gas in that thermometer are very sensitive compared to mercury thermometers. Having a large contact angle between mercury and glass is an advantage for accurate readings in mercury glass thermometer. Having a large angle of contact, yes, it is correct because when the angle of contact is large, so you will see the mercury column as this. You will see this mercury column like this, like this. So you can easily read this. You can easily read this, right? So answer is 3, right? Answer is 3 because when volume increases, sensitivity increases. When volume increases, sensitivity increases, right? Not the range. Sensitivity increases. For 6, answer 3. Okay. 7. 7. Consider the following statements regarding the physical properties of ultraviolet and ultrasound waves. Ultraviolet and ultrasound. What are ultrasound waves? Ultrasound means ultraviolet, you know, UV. Ultraviolet can UV, right? Ultraviolet. And ultrasound means the waves with frequency greater than 20 kilohertz. Ultrasound means waves with frequency greater than 20 kilohertz. Ultrasound, right? That we don't hear. That is not in our audible range. Energy of both waves depends on their frequencies. No, the reason is this: frequency of an ultrasound wave is independent of energy, right? When it comes to the ultraviolet, ultraviolet is an electromagnetic wave. This is electromagnetic. This is electromagnetic. So electromagnetic wave follows E equals HF. Electromagnetic wave follows E equals HF. Right? Electromagnetic wave follows E equals HF. But when it comes to ultrasound, it doesn't depend on frequency. Energy doesn't depend on frequency. Right? For ultrasound, because E equals HF is valid only for electromagnetic waves. Right? This doesn't depend on frequency. And for A levels, we don't have that equation of ultrasound waves. Ultrasound in the sense that is longitudinal waves. You don't have that relationship between energy and frequency. I mean, the relationship is not there as an equation, right? So there's no relationship at all. Now fine. Okay. Both waves have the ability of ionizing materials. Both waves has the ability of ionizing materials. What do you say? Only electromagnetic waves can ionize materials, right? Only electromagnetic can ionize materials. For statement A, and for statement B, only electromagnetic waves ionize. Only electromagnetic waves can ionize. Material. Only electromagnetic waves. And C, both waves can be polarized. No, because longitudinal waves cannot be polarized. Sound waves are, any sound wave is longitudinal, right? So this one, longitudinal waves cannot be polarized. Longitudinal waves cannot be polarized. So therefore, all three are incorrect. Which statement are incorrect? All three. All A, B, C. Answer 5. For 7, answer 5. 8. An object is moving in a circular path at a constant speed v as shown in the figure. The change in velocity of the object when moving from A to B is, right? Change in velocity. So you know that moves in a circular motion, right? That travels in a circular motion. And velocity of a circular motion is always tangential, right? Velocity is along the tangent, that is tangential. So this velocity will be tangential like this, and this velocity here is also tangential like this, right? So we need the change of velocity, change in velocity, right? So delta V can be written as what are the points A and B. So delta V can be written as final velocity minus initial velocity, right? So delta V is change in velocity is VB minus VA. VB is vertically upwards V, minus VA is to the right V, right? Now I can write the same as this by making this plus. We can write this, right? Now to simplify these two, we can use what? We can use vector triangle. These two vectors, these two are vectors. So we can use vector triangle to solve this. one vector is this and the other vector is this. So the resultant gives by this, right? So if there is V and V, this is going to be root 2V because root V squared plus root V squared. This will be root 2V. And V and V, this angle is exactly 45. V and V, which means this angle is 45. This also 45. So that should be root 2V along that direction with 45. Answer 4. Point answer 4. Point answer 4. Take it down. Now this is kind of a tricky question and a good question. Right. Nine. Question 9. A weightlifter lifts a weight vertically up, positive direction, with his hands. The signs of the work done by his hands on weight, gravity on weight, and okay. A weightlifter lifts a weight up, something like this. Okay, something like this. A weight on hands. A weight on hands. Right? First one is his hands on the weight. His hands on the weight. Okay, gravity on the weight. Okay. Now these are the reactions. There will be one reaction on weight like this. And mg will be acting on weight like this. Mg acting on weight. And the equal and opposite reaction of that reaction acts on hand like this. Okay, then right. The signs of work, right? So we know work is F times S, so F into D, right? So you all know, work can be written as force into displacement. Force into displacement. Now for the first scenario, simply for the first scenario, his hands on the weight. His hands on the weight. That is about this way, right? His hands on the weight again this force, right? Now it is going to take up like this. So which means in this scenario, force is also positive direction, right? Upward direction positive, and S is also positive. So this is positive. And in B, gravity on the weight, gravity. Mg is due to gravity. Mg is due to gravity. Now Mg is downwards, that is minus, opposite directions. And H is plus. So this is minus. This is a minus work. And C, the weight on his hands. Weight on hands can this R, that R is downwards. So therefore, that is also minus, but H is plus. Still, this is minus. So it should be minus, sorry, plus minus minus. It should be plus minus minus, answer 3. For 9, answer 3. For 9, answer 3. Okay. 10. 10. Consider the following statements regarding a 3-level laser system having energies E1, E2, and E3. E1 greater than E2, sorry, E1 less than E2 less than E3 as shown in the figure. The laser action occurs between energy levels 2 and 1. Laser action occurs between energy levels 2 and 1. That is correct. See, let me take this down. 3, 2, 1. This is level 3, level 2, level 1. Right? So in laser production, what happens is, now this is the base level of photons, and they will be pumped to this level. They will be pumped to level 3, and this is called a metastable level. This is called a metastable level. Metastable. And laser action always occurs from metastable level to base level. Right? From metastable level to base level. Therefore, the laser action occurs between energy levels 2 and 1. That is correct, because 2 is a metastable level. The frequency of pumping radiation is E3 minus E2 OH. No, because pumping is done from here to here. From here to here, this is the pumping. This is pumping, right? So the frequency of pumping energy will be apply equals HF. Right? Now E is E3 minus E1. E3 minus E1 equals HF. So that frequency is E3 minus E1 over H. Given answer is wrong. Given one is E3 minus E2, that is wrong. And C, level 3 is known as the metastable energy level. Level 3 is known as, no, level 2 is metastable, I told you. Level 2, the intermediate level is a metastable level, right? Because always when photons are pumped, so after some time, after 10 to the minus 3 seconds, around a time of 10 to the minus 3 seconds, it comes to the metastable level, right? That is a bit less than the pump level, right? So metastable level is E2, right? Level 2, E2. Then which of these statements above are correct? Only for 10, answer 1. For 10, answer 1. For 9, what was the answer? 3, ne? I haven't mentioned. Yeah, for 9, answer 3. Okay, first 10 questions are done. First 10 questions are done. So if there's anything you can take down. If there's anything you can take it down. Right, 11. Consider the following statements made regarding the velocity of sound in Earth atmosphere. 11. 11. Consider the following statements made regarding the velocity of sound in Earth atmosphere. It does not change with altitude at constant temperature. Correct, because velocity of sound, this is the equation. V equals root gamma r T over m. Right? So velocity of sound, this is very special. V depends only on temperature. V depends only on temperature, right? So we are in 11. We have 3 statements A, B, C. So let's see them one by one. A, it does not change with altitude at constant temperature. Yes, if constant temperature, if the temperature is constant, no change in velocity according to this equation. B, it always increases with decreasing pressure. Increases with decreasing pressure. Wrong, because I told you V depends only on T. Pressure depend on, right? It is independent of pressure. Depend only on T. So that is wrong. C, it decreases with increasing altitude as a result of decreasing temperature. Increasing altitude as a result of decreasing temperature. Yes. If temperature decreases, V decreases. If temperature decreases, V decreases. So C is correct. So which means A and C. Only A and C, answer 4. For 11, answer 4. For 11, answer 4. 12. Which of the following statements regarding the X-ray production in common applications is incorrect? 2 circuits are used in X-ray production system. Yes. One circuit is the main circuit. Right? Roughly in X-ray production, this is what you have. You have the X-ray bulb like this. the X-ray production bulb like this. Show it here. The X-ray production bulb is something like this. I'll be drawing the rough diagram, right? A rough one. And here, this is one of the circuits. And this is the target. This is the target. And target is connected to a high voltage supply like this. High voltage supply like this, right? So one circuit is here. This is the main loop. This is the main loop of X-ray production. And this is the other loop, second loop of X-ray production. So that is two circuits. Two circuits are useless. Anode could be damaged due to the bombardment of electrons. Yes, because electrons which are coming from the cathode. This is the anode. This is anode. This is cathode. Electrons which are coming from the cathode with a very high velocity, very high kinetic energy, hits on the anode metal. Right? Hits on the anode metal. Right? So it can damage the anode. Low voltage is sufficient to heat the cathode. Low voltage is sufficient to heat the cathode. Correct. That is here. When cathode heat this one heats the cathode. So that's a low voltage. And this is a high voltage. This is a low voltage. This is a low voltage. And this voltage is a high voltage. High voltage is used to accelerate electrons. Because when this high voltage changes, the voltage difference between anode and cathode changes. With that change, the acceleration on electrons will be changing and it will increase. With a high voltage, acceleration increases. Right? 4. Energy of X-rays emitted depends on the current through filament. No. Energy of X-rays, point. Energy of X-rays depends with the acceleration. So therefore, it depends with the high voltage supply. It depends with the high voltage supply. Right? Not the current of the filament. Not the current. Now with the current, intensity of X-ray production increases. Right? Higher the current means higher number of electrons are produced. So with that intensity means that the number of electrons hitting the anode per unit time, that increases. Intensity increases, but energy doesn't increase. Energy depends on this high voltage supply. Incorrect. So incorrect one has to be 4. Let's see 5 and come back. X-ray tube must be evacuated to avoid the energy loss of electrons. Yeah. So here there's another tube used. Here there's a tube used for evacuation. There's a tube used for evacuation. Right. So you have to know this setup. So incorrect one is answer 4. Incorrect one is 4. Answer 4. For 12, answer 4. For 12, answer 4. Thirteen. Consider the following statements regarding the dew point of air having water vapor in a closed container. Okay, 13. ABC. Consider the following statements regarding the dew point of air having water vapor in a closed container. A. At dew point, unsaturated water vapor becomes saturated water vapor. Correct. Because dew point is the point where the saturation becomes 100%. So where the saturation starts to become 100%. Right? So unsaturated water vapor becomes saturated. A is correct. A is correct. B. If the temperature is reduced below the dew point, some of the water vapor will condense. Yeah, that is called dew. That is how dew is formed. Right? So you all know what dew is, ne? You all know what dew is. That is actually how dew is formed. That is also correct. Dew forms. Right? Dew is the condensed water vapor. Dew water means condensed water vapor. Right? See, at dew point, if the volume of container is reduced, the absolute humidity of the air will decrease. What is absolute humidity? absolute humidity is X is M over V. Absolute humidity is X is M over V. If the volume is reduced, so if volume is reduced, absolute humidity increases. So therefore, it is not going to decrease. So that is wrong. Correct, wrong. Only AB. Only AB are correct. So answer 3. For 13, answer 3. For 13, answer 3. Answer 3. Right. So you can ask anything. Right. Next one. 14. When the tension of a wire is slowly increased from T1 to T2 within the proportional limit, its length changes from L1 to L2. The energy stored in wire during the process is. Okay. So we know the variation between F and length is something like this in proportional limit. Something like this in proportional limit. Right? Now this increases from T1 to T2. This increases from T1 to T2. And the length increases from L1 to L2. Right? So energy stored is given by area under curve. Energy is area under curve. Area under curve is strain energy. Area under curve is strain energy. Energy stored in the process. Yeah. Then take this area under this curve. Take this area under this curve. So that is a trapezium. So this is T1 plus T2. T1 plus T2 over 2 times perpendicular height L2 minus L1. L2 minus L1. Right? Answer 5. Answer 5. 14. Answer 5. Now, if you know these things, that is going to be very much easier. Now, without knowing the graph or knowing equations, you can't argue in the question, right? So it's a must to know these equations and graphs. They are straight from theories. 15. Hydrogen gas in a container is maintained at standard temperature 300 kelvins and pressure 1 times 10 to the power 5 Nm minus 2. If the root mean square speed of hydrogen molecules is 2 kilometers per second, what is the density of hydrogen in the container? Right. So that is also coming from a proved equation. We have, right? Density is given, very straightforward. Density is given. What else? Root mean square speed, right? Density and root mean square speed. Again, that is very straightforward. That is an equation we are proving. That is P equals 1 over 3 rho C squared. Rho C squared. Right? So this is an equation we are proving in gas expansion. P equals 1 over 3 rho C squared. Right? So directly apply this equation. So we can directly apply the equation. Right. What are the given values? 1 over 3. Sorry, pressure is given. Yeah. Then if we need rho, let me subject rho first. We need rho. So rho is given by, 3p over c squared bar. 3p over c squared bar. This is 3 times pressure. Pressure is 10 to the power 5 over c squared bar, that is given in 2 kilometers per second. So which means we have to convert this 2 times 10 to the power 3, and that's a root value. That's a root mean square value. 2 times 10 to the power 3 whole thing squared. Simplify this. 3 times 10 to the power 5 over this is 4 times 10 to the power 6. Correct? Sorry, 9. That is given in kilometers. All right. Square 6. Yeah. Then this is 0.304 and 0.75. 0.75. This is 10 to the minus 1, which means 0.075. 0.075. It's the answer to 15. Answer 2. A composite rod is formed by connecting two rods A and B as shown in the figure. Longitudinal wave velocities in rod A and rod B are 3210 and 6420 respectively. A longitudinal pulse applied at the free end of the rod A propagates with the wavelength 2 meters. What's the wavelength of this wave when it propagates through B? Okay. Now, since velocity and wavelength lambda are known, which means frequency of rod A can be determined. So first I will be doing this. Say 16. First, what we can do is we can apply V equals F lambda for A. V equals F lambda for A. And V is 3210. Right? Equals F times lambda is 2. So F here is 3210 over 2. Frequency is constant in both rods. Both rods are connected in a series combination, right? So in series combination, frequencies are constant. Frequencies are constant. Now again, we can do the same for B, right? Very simple. Very simple. Do the same for B. Again, this is V equals F lambda for B. Now V is given 6420. 6420 equals F is here times lambda, right? Now this is exactly 2 times of this. So which means lambda equals 4 meters. Lambda equals 4 meters. Answer 4, 16, 4. For 16, answer 4. Right. For 16, answer 4. So you can take down if there's anything. 17. The magnitude and the direction of electric field at point A due to the point charge distribution shown in the figure. Okay. Now there are something like this. There are something like this. If same charge is given at a same distance, their mutual forces will cancel each other and they are going to cancel. Now let me take down the diagram first. 1, 2, 3, 9 charges, 8 charges, 8 charges. So it's like this. The charges are placed like this. The charges are placed like this. And this is point A. Right? Plus Q, plus Q, plus Q. Plus Q, plus Q, plus Q. And plus 3Q, plus 3Q, plus Q, minus Q, plus Q. See, now this is the point A, my interested point, right? Look at here. Now, if I consider 3Q, right? If I consider 3Q, now distance for this upside 3Q and downside 3Q are same. If distances are same, the forces are going to cancel, right? Now, as an example, the force between, they're asking about not the force, electric field, right? So anyway, it also cancels. Electric field from a positive charge is away from the charge. So electric field, direction of electric field from this positive charge is downwards, away from the charge. And electric field of this PQ here is upwards, away from the charge. Right? Since they are equal charges in same distances, they are going to cancel each other. So likewise, this 3Q2, this 3Q cancels. This Q2, this Q cancels. And this Q2, this Q cancels. Only these two remains. Only these two remains. Only these two remains. Right? Which means direction of electric field due to a positive charge is away. So which means direction of electric field due to this plus Q is away from this like this. And direction of electric field due to a negative charge is towards the negative charge. Towards direction of this is also the same. So which means net direction of this electric field is going to be this, to the right. To the right. So there is only one answer with a right direction. There is only one answer with a right direction, right? So if you are writing the magnitude can be written like this. This is 1/4 epsilon naught, right? Q over what's the distance? A, ne? Yeah, distance is A. So which means Q over A squared such 2. Right? Answer 1 for 17. Answer 1. So you have to know these equations. Now, without knowing equations, you can't do anything. Right? Knowing equations is a must. Knowing equations is a must. Right? 18. Three capacitors with equal capacitance and two batteries with equal electromotive force EMF are given to construct a circuit to store energy. Which of the following circuits stores the maximum energy? Okay. 18. This is the argument. This is the argument. First thing is energy stored in a capacitor is half CV squared. So energy stored in a capacitor is half CV squared. Therefore, to increase energy, to have the maximum energy, C and V both should be maximized, right? So my decision is both C and V should be maximized, right? Both C and V should be maximized, right? So you all know that in series combination, capacitance is added as 1 over capacitance. So therefore, in series combination, capacitance decreases. In parallel combination, capacitance increases, right? And when it comes to cells, in series combination, electromotive forces add up, so it increases. In parallel combination, it doesn't increase, right? So therefore, now to increase V, to increase C first, capacitor should be parallel. And to increase V, right? This is capacitor. Capacitors should be parallel. Capacitors should be parallel. And here, batteries should be series. Right? That's the argument. Capacitors are parallel, batteries series. Answer 3. Ne? 18, answer 3. 18, answer 3. Right? So if you know these things, you can easily get these answers. You have to know it. You have to know. Okay. 19. When a current of 6 amperes is flowing through the primary coil of an ideal transformer having power of 60 volts, output voltage is 12 volts. Select the correct answer which gives the type of the transformer and the current ratio, primary current to secondary current. Okay. So we know 19. We know P equals VI. P equals VI. Power is given 60. Right? And V is V we don't know. I is given. So V into I is 6. Right? So which means V equals 10 volts. V equals 10 volts. Primary coil, that is called V1. So primary coil, that is V1. So V1 is 10 volts. Now the secondary coil voltage is output voltage is 12 volts, which means V2 is 12, right? Which means V2 is 12, right? Since V2 is greater than V1, since voltage of secondary coil is greater than voltage of primary coil, there is a step up transformer. There is a step up. There is a step up transformer, right? And the equation of a transformer is this equation of a transformer. V1 over V2 equals N1 over N2 equals I2 over I1. Right? V1, V2 are voltages, N1, N2 are number of turns in the coil, I2, I1 are currents. Right? Now, since V1, V2 are known, so I'm going to use this relationship here. V1 over V2, V1 was 10, V2 12 equals I2 over I1. We need I1 over I2 primary to secondary. You need I1 over I2. So therefore, I1 over I2 equals 12 over 10, which means 6 over 5. Step up 6 to 5. Step up and 6 to 5. Step up and 6 to 5. Answer 5. For 19, answer 5. For 19, answer 5. A coil is made by winding n number of turns around a plastic ring of mean radius capital R and cross-sectional area capital A. Right. As shown in the figure, this coil is placed coaxially with a long straight wire carrying a current I. If the rate of change of current through the straight wire is I naught cos omega t, rate of change of current. So which means this is given 20. 20. Rate of change of current that is delta I over t. This is given as I naught cos omega t. That is given as I naught cos omega t. Which of the following expressions give the electromotive force EMF induced in the coil? Right. So we know induced EMF can be written as induced EMF from Faraday's laws. From Faraday's laws, induced EMF can be written as delta BAN over T, delta BAN over T, delta BAN over T. Right? B from a wire can be written as mu naught over 4 phi when wire is to both sides, that is 2I over R. Right? That is 2I over R. Now, if I simplify this further, right, this 2 cancels me. So that is mu naught I over 2 phi R. R is given, capital R. Mu naught I over 2 phi R. B is known. Now I'm going to plug that B here. See? Plug that B here. B should be mu naught I over 2 phi R. And here, what remains is A N over T. Now I have an answer for I over T. I have an answer for I over T. I over T is I naught cos omega T. Right? So which means equals. Now what remains is this mu naught A N over 2 phi R remains. And for I over T, I can use I naught cos omega T. Right? Mu naught A N over 2 phi R, I naught cos omega t, 4. For 20, answer 4. For 20, answer 4. Now, this is a good question. Right? Magnetic fields. So, these are different data given. And this is about magnetic flux density from a current carrying conductor r distance away. So, that is coming from that equation. And this is from Faraday's laws, electromagnetic induction, Faraday's laws. Right? Then for 20, answer O. Write down. Write down, write down. Next. 21. 21. Consider the points A, B, and C on two equipotential surfaces as shown in the figure. When a proton moves from A to B, the electric field does a work of 3.2 times 10 to the minus 19 joules on it. Charge of an electron is minus 1.6 times 10 to the minus 19. The electric potential difference VAB, VBC, and VCA. VAB, VBCN are right. VCA. No need to find VCA because VCA is 0. That is an equipotential surface, right? So VCA is very straightforward. VCA equals 0 because that is equipotential. Equipotential. Equipotential means potentials are same along that line. Along that line, potentials are same, equipotential, right? To determine VAB, now A and C are same, A and C are same, which means now if I get potential difference between A and B, potential difference between B and C will be same as to potential difference between D and A because that's same, right? So we'll apply an equation like this. We can use W equals Q delta V for any moving charge in an electric field. W equals Q delta V for any moving charge in an electric field. For any moving charge, W is work. Work is 3.2 times 10 to the minus 19. 3.2 times 10 to the minus 19. And Q, that's a proton. Electron charge of an electron is given, that is minus 1.6. So charge of a proton is plus 1.6 times 10 to the minus 19. And here delta V is, it is taken from A to B. It is taken from A to B, which means delta V is VAB. A to B, A to B. Right? Simplify this. 2, these 2 also cancels, which means VAB equals 2. 2 volts scale again VAB. Right? If VAB equals 2 volts, therefore VBA equals minus 2 volts. VBA equals VBC. VBA equals VBC. Since VA equals VC, this also equals to VBC minus 2 volts. Minus 2. So which means plus 2, minus 2 and 0. Plus 2, minus 2 and 0 for 21, answer 1. For 21, answer 1. Plus 2, minus 2 and 0. Plus 2, minus 2 and 0. A small calculation, that's a small one, small calculation. Okay, 22. A celestial object is located at midpoint of the line joining the centers of Earth and Moon. Something like this. The object is placed at the line joining Earth and Moon. Let's say Moon is here and Earth is here. Right? Yeah, Earth and Moon, like this. Then, at a certain time, the mass of Moon is 0.0123 times mass of the Earth. Right. Then if I consider mass of Earth as m, this is 0.0123 m. 0.0123 m. Assume that the distance between the centers of Moon and the Earth is 60 times of the radius of Earth. 60 times the radius of Earth. Right. The distance between the centers of Moon and okay. Now this is kept at the midpoint, it says, right? Midpoint. So which means now from the object, this has to be 30 r, and this has to be 30 r, 30 r and 30 r. The acceleration of object due to gravity of both the Earth and Moon in terms of g approximately, right? Now on this there are two forces exerted by Earth and Moon, right? In gravitational fields we only have attractions, gravitational attractions. So this is the attraction towards Earth, this is the attraction towards Moon, right? Now if we need acceleration, we know F equals ma, right? If we need acceleration, F equals ma, right? So I'll apply that in this direction. So which means it should be Fe minus Fm equals ma, right? Now expand this, expand this. So we know gravitational force can be written as, very popular, and I wrote the same equation in one of the first questions as well. F is G m1 m2 over r square, gravitational force. Simplify this. Then this has to be, Fe has to be G times, Fe has to be G times m simple m, let's say this one is simple m, over r squared, that is 30 r squared, right? Minus, this is G, and m of the Moon is 0.123 m, simple m, over 30 r holding squared, simple m a, simple m cancels throughout, simple m cancels throughout, Gm over 30 r squared can be taken out, right? So I'll take it like this, Gm over 30 squared is 900, right? So this is 900 r squared. Within brackets, 1 minus this value remains 0.0123, yeah, 0.0123, 0.0123, this remains, equals a. In terms of g, so we know this is a proved equation, you have to know this, g equals Gm over r squared on Earth surface, right? Then for Gm over r squared we can put g, right? For Gm over r squared we can put g, this is g. So therefore this is the number you need to simplify, this is g times this is the number 1 minus 0.0123 over 900. This number should be simplified. Let's see. Now there's a simplification here. There's a small simplification here. 1 minus 0.0123 over 900. That is 0.00109. This is 0.00109. Now 1.1 can, it's a rounded answer given, right? It's a rounded answer given, so I can round this up to this. So we can write this as 0.0011, right? So which means 1.1 times 10 to the power minus 3g, 1.1 times 10 to the power minus 3, right? Times g. Answer 2 again, 22, answer 2. No, that's a good one with a simplification. We have a simplification to do. You have a simplification to do. Right? 23. the gap of 2 centimeters between two horizontal plates of surface area 500 square centimeters is filled with an oil having the coefficient of viscosity 0.2. The horizontal force of 5 newtons is applied to the upper plate, something like this. 23, something like this. This gap is 2 centimeters, and this is filled with that oil. And for this upper one, the force is applied 5 newtons, and the surface area is 500 square centimeters, right? For giving the overplate as rest, what is the velocity of the middle layer of oil if the velocities of the oil layers vary linearly across the gap between the plates? Okay, that's linear. Now, using Newton's equation, I'm going to determine the velocity of the upper plate. Using Newton's equation, you can use Newton's equation and determine velocity of the upper plate. Velocity of the upper plate. What is Newton's equation? F equals eta A V1 minus V2 over D. Newton's equation. F is 5 newtons and eta was 0.2. A is 500 square centimeters, so 10 to the power minus 4, right? And this is V minus 0 over D is 2 centimeters, 2 times 10 to the power minus 2. Simplify this. This is 0.2 times 10, right? Which means 10 and 10 to the power minus 2 get 10 to the power minus 1. So when it comes to here, it will be 10 to the power plus 1. So 10 to the power minus 3 remains. 10 to the power minus 3 with this one 5 to 100 minus 3 with 100 minus 1 remains. So which means V equals 10 to the power 1. So V equals 10 ms minus 1. V equals 10. If V equals 10 and if it linearly distributes, right? Now you can deduce the answer. In the middle layer, it should be 5. So if you need to get it, you can do it like this. It should be 10 plus 0 over 2. 5 ms minus 1 in the middle layer. 5 again, answer 2. For 23, answer 2. For 23, answer 2. A diode and a resistor are connected in such a way. A diode and a resistor is connected in such a way that only 2 terminals are available for external connections. 2 terminals are available for external connections. Okay. So which means external connection in the sense that has to be the battery or the external voltage supply. When a voltage of 1 volt is applied across the external terminals, above external terminals, the current through the circuit is 50 milliamperes. When the applied voltage is reversed, the current doubles. What are the forward bias resistance of diode and the value of resistor? A good question. So there are few arguments for you to know. Right? Look at here. Now, since currents are flown in both directions, which means diode and resistor has to be parallel, because if they are in a series combination, in the reverse biasness, no current flows through the diode. When a diode is reverse biased, no current flows. If they are in a series combination like this, then there shouldn't be a current in the circuit. Now we have currents in both cases, which means diode and resistor are parallel. That is first decision. First decision is diode and resistor are parallel. So it should be something like this. Diode here and the resistor here. Something like this. Right? And they are connected using their external terminals to a battery. They are connected to the battery like this, using these 2 external terminals. something like this, and this is given as 1 volt, 1 volt. And when the voltage is reversed, the current doubles, which means we know when a diode is reverse biased, its resistance is maximum. When a diode is reverse biased, this is something you have to know. When a diode is reverse biased, resistance of a diode at the reverse biasness is maximum, and resistance of a diode at the forward biasness is minimum. Right? Now, the lower current is at the first case, 50 milliamperes is at the first case, which means lower current has to be with the maximum resistance. So, in the first case, diode should be reverse biased. So, therefore, this battery is connected in the other way. See, that's a decision we have to make. That's a decision you have to make. So, in this first scenario, the battery should be like this, and that current flows in this circuit, and that current flows in this circuit like this, and that is 50 milliamperes. Okay, now R can be determined. Right? Let's say R1 and R2. R1 can be determined. This is 1 volt. Use V equals IR for this resistor. V is 1 volt, I is 50 milliamperes, 50 times 10 to the minus 3, R1. So R1 is, this is 1000 over 50. So R1 is 20 ohms. R1 is 20 ohms. Right? And the second scenario is, now this is reversed. So the second scenario has to be like this. Second scenario has to be like this. Second scenario has to be like this. Now the diode is forward. When the diode is forward, current is doubled. So which means a current of 100 milliamperes flow here. A current of 100 milliamperes flow here. And this is known now. This is 1 volt still, 1 volt. And this is known now as 20 ohms. We need R2. Now again, see, a very small argument. Now potential difference across the resistor is still the same, and resistance is also the same, which means current flow across the resistor has to be same. So therefore, in this case also, a 50 milliampere current flows through the resistor, which means again a 50 milliampere current must flow through the diode. Right? So 50 milliampere current must flow through the diode. Right? Then apply V equals IR again. Considering the entire circuit, V equals IR for system, because for diodes we can't apply V equals IR. For diodes you can't. I'm going to apply for the system and get the total resistance done. Right? If the total resistance is known, we can determine the resistance of the diode here. Right? V equals IR for system. Right? V is 1 and current is 100 now. 100 times 10 to the minus 3 R. Right? R total, RT. R total. Right? Now RT will be, what's the value? 10 ohms. But we know these two are in a parallel combination. So therefore, 1 over 10 equals 1 over 20 plus 1 over R2. Right? Simplify this. So 1 over R2 equals 1 over 10 can be written as 2 over 20 minus 1 over 20. Again 1 over 20 comes, which means R2 is 20 ohms. So both R1 and R2 are 20. Both R1 and R2 are 20. 20 each. For 24, answer 5. For 24, answer 5. 24, answer 5. Twenty-five. This is also a good question with a decision to make. Right? Decision is this. You have to make this decision. Right? Diode and resistor are in a parallel combination. And since the resistance of diode at reverse biasness is greater, lower current of the circuit has to be at the reverse biasness. So likewise, decisions must be made. Decisions must be made. 25. An air mass in a cyclone moves around its eye in a spiral path as shown in the figure. The velocity of air mass at a radial distance is 80 kilometers from the center of the eye is 150 kilometers per hour. What could be the velocity of same air mass a radial distance of 40 kilometers from the center of the eye? That is very straightforward. Angular momentum, right? So you can use angular momentum, 25. So we know angular momentum can be written as either I omega O as mvl, right? So I'll be writing it as mvl because velocities are given, right? Then for the first case, let's say m is m, and for the first scenario, v is 150 at 80, 150 at 80, right? And second scenario, same m, we need v at 40. So this is 40 times 2, very straightforward, m to m cancels. So v equals 300. V equals 300. Answer 4. For 25, answer 4. 26. An analog multimeter is connected to a circuit shown in the figure. The reading of the multimeter is right. First you have to check in which meter this multimeter functions now. So you can check it from the indicator. Now the indicator is connected to indicator is rotated to 2 volts, 2 volts, and that meter is given as DCV. DCV means DC voltmeter, right? So that meter is DC voltmeter, and 2V means maximum deflection of that DC voltmeter is 2 volts, right? For 26, so that's a voltmeter of maximum deflection 2 volts, right? Now it acts as a voltmeter. Now it works as a voltmeter, right? So DC voltmeter can be read from the scale in between. That is mentioned. You can see it, right? From right hand side, below one is AC voltmeter, and the second one is DC voltmeter, and the last one is ohm meter, right? So the middle one is the DC voltmeter, and DC voltmeter is divided into 10 divisions. But its maximum deflection is 2 volts. It divides into 10 divisions. So one division means 1 division equals 2 over 10, which means 0.2 volts. Now the indicator is at 7. So therefore, voltmeter reading is 7 times 0.2, 1.4 volts. 1.4 volts. Answer is 3. For 26, answer 3. Answer 3. (27) A large number of point charges are uniformly spread out over an unconducting ring of radius r. If the total charge of the ring is q, what is the electrostatic potential at point P on the axis of the ring as shown in the figure? D distance away, right? So this is actually a proved equation. Now, if you know the proved equation, right? If you know the proved equation, you can easily get the answer. Answer is 4. This is a proved equation. So if there's anyone who don't know how to prove, I'll show the proof. Otherwise, this is a proved equation, right? In electric fields, electrostatic fields. 27. This is the scenario given. R and D, P is here, and this is D, this is R, right? So which means this distance from here to here is root R squared plus D squared, right? So we know potential at a point can be written as 1 over 4 pi epsilon naught by a point charge. By a point charge, we can write it as Q over R squared. q over x squared or distance squared. Right? Now let's assume this consists of simple n number of point charges. The given capital Q charge is totally is Q, totally is capital Q. So let's assume it says a large number of point charges. So let's assume one charge is simple Q and large number of point charges, let's say n number of charges are there and total has to be Q, right? Then by 1 point charge, now if there is 1 point charge here, let's say Q, by this 1 point charge, potential at this point is Q over distance is now this r squared plus d squared. Such n charges are there. So what do we know? Q times n is capital Q. So V is 1 over 4 5 epsilon naught Q times n is capital Q over root r squared plus d squared. Right? Answer 4. For 27, answer 4. The human blood circulatory system consists of about 1 billion 10 to the power 9 capillary vessels, each with an average diameter of 8 micrometers. If the blood is pumped from the heart at a rate of 5 liters per minute, what is the average speed of blood flowing through the capillary vessel in centimeters per minute? So first thing you have to know, 1 liter is 1000 cubic centimeters. That you know, 1 liter is 1000 cubic centimeters, right? Now the volume flow rate is given. So we know from continuity equation and Bernoulli's theorem, fluid dynamics, right? Volume flow rate can be written as AU. Volume flow rate can be written as cross-sectional area into velocity. So that is how the continuity equation comes. Continuity equation is A1V1 equals A2V2. So that's the product of cross-sectional area times velocity, right? Now V can be written as 5 liters per minute. 5 liters per minute. So I need to convert that liters to cubic centimeters. For that conversion, 1 liter is 1000 cubic centimeters. Right? Now this is in cubic centimeters. And time is in minutes. So that is fine. That is just fine. 1 minute. Okay. Per minute. And area is a 5r squared. So 5 and r here has to be, diameter is 8 micrometers. So r is 4 micrometers. 4 micro means 10 to the power 6. So this is 5r squared times this times 10 to the power 9, because there are 10 to the power 9 capillary tubes, right? Capillary vessels. There are 10 to the power 9 capillary vessels. Times U. Right? And here there's another conversion. Because now if I convert to meters, again it is not going to come. We need the value in centimeters. So convert this to centimeters. Yeah, that's a good point. So convert this to centimeters. What's the difference? Centi can 10 to the power minus 2. Right? Milli is 10 to the power minus 3. Micro is 10 to the power minus 6. So gap between these two is 10 to the power minus 4. So therefore, times 10 to the power minus 4 squared U times 10 to the power 9. Simplify this. Okay. Then here 5 times 10 to the power 3 comes. 5 times 10 to the power 3. And 5 comes here, and this is 16. And from here 10 to the power minus 8. And this is 10 to the power 9, which means 10 remains. 10 U. Okay, then this 10 to, this is also cancelled. So this is 500 over 16 5. U equals 500 over 16 5. So it can be written as 125 over 45. 125 over 45. Yeah, it's there. Answer 5. For 28, answer 5. That's also a good question with a conversion of units. With a conversion of units. Now, if you didn't convert the unit properly, right, you might not get that value in centimeters per minute, because the value is asked not in the standard unit, that is asked in the centimeters per unit, centimeters per minute, right? So when you convert, you have to be a little bit careful. 29. Two thin spherical metal shells are placed concentrically as shown in the figure. Inner shell is kept at a potential V while the outer shell is grounded. Okay, the variation of electric field E with distance from the center is best represented by. Right. Now, this is one conductor and this is another conductor. This is kept at V. Okay, this is given. So let's assume the charge on this sphere as Q. Right. Charge on that sphere as Q, and this is grounded. Right. Right. Now, if the charge is Q, there is no charge inside this thing. Right. There is no charge inside this sphere. If there is no charge, no electric field. Right. So therefore, let's say R it is given. So therefore, so we know electric field intensity is 1 over 4 pi epsilon naught Q over x squared. Right. But when x is less than R, E becomes 0 because there is no charge. When x is less than R, E becomes 0. Right. And here there will be a non-zero E. Because a potential difference is there. Correct? So we know E is delta V over D. If there's a potential difference, there's E. So therefore, we have E here. So when x equals R, let me write it. When x equals R, E is non-zero. Right? So when moving on, if I consider somewhere like this, the distance from the charge increases. When distance increases, electric field intensity decreases. So that should be a decreasing trend. Right? And finally at here, if I check the value, still at here also. Now, if I check the value still at here also, there is a non-zero charge inside. So that should be non-zero, right? So when x equals R also, capital R also, that is non-zero, right? Because just before that, there was a charge. So that is not going to go to 0. That should be non-zero. Right? Answer is 2. Because we have to tie between 1 and 2. Right? 1 and 2 tie we know E equals 0. Equals 0 equals 0 4 and 5 are omitted. Right? And other than that, I know E decreases with the time. E decreases with the distance. Right? 3 is also row. So we have to tie between 1 and 2. Right? Then if I check here also, there's a charge inside the Gaussian surface. Right? So that is non-zero. Answer 2. 29. Answer 2. 30. An ideal gas expands from state A to state C along two different paths, ABC and ADC, as shown in the PV diagram. The heat absorbed by the gas during the processes AB and BC. So these are given. Delta Q, AB. What's the value? 200. Delta Q, AB is given 200 joules plus absorptions are plus, emissions are minus, liberations are minus. Delta Q BC is plus 700 joules. Respectively, what is the change in internal energy when the gas expands along path ADC? Change in internal energy. Right? Internal energy depends only on final and initial points, or initial and final points. Right? It depends only on initial and final points. So therefore, now if the process goes from ADC, A to D to C, or A to B to C, that doesn't matter. Initial and final points are same. So therefore, internal energy remains same. Considering that, I'm going to apply first law of thermodynamics for the path ABC at once like this. So we can write as delta Q ABC equals delta U ABC plus delta W ABC. Delta W ABC. Right? Delta Q ABC can be written as delta Q AB plus delta Q BC. That is here. And delta U ABC can be written as delta U AC because it depends only on initial and final points. Delta W ABC can be expanded as delta W AB plus BC. But there is no work done in a vertical line. So AB is 0. So therefore, this is only delta W BC because delta W AB is 0 vertical. Right? Okay, then this can be delta Q AB plus BC. 200 plus 700, 900. 900 equals, we need delta U AC. And delta W can be written as area under curve. It can be written as area under curve. Area under curve. So area under that curve is height is 6 times 10 to the power 4. 6 times 10 to the power 4 times 3 times 10 to the power 3 minus 3. 3 times 10 to the power minus 3. 180. 180 kilogane. Delta UAC equals 180 720. 720 joules. 720 joules. 720 kilogane answer 3. For 30 answer 3. For 30 answer 3. $31. A ball is dropped freely to a floor. A ball is dropped freely to a floor from a height of 1 meter. If its speed is reduced by 25% at each bounce, what would be the height of the ball reaches after 3 bounces? Okay, something like this, 31. Okay, the ground is here. So it comes down and do the first bounce and goes up and comes down for the second bounce and then third bounce. Likewise, it goes. Right? Likewise, it goes. So let's say the ball is dropped to a floor from 1 meter. Okay. Now, first I'm going to determine the velocity of this ball here. Velocity of the ball. I need the velocity of the ball here. Right? So we know we can use v squared equals u squared plus 2a, and this is given as 1 meter. Right? Then v squared equals u squared is 0, 2, let's say g, 2g into 1. So which means v squared equals 2g. So having that in hand, now let's argue about the other velocities, right? Now what we need is what would be the height the ball reaches after 3 bounces. First bounce, second bounce, third bounce. So again, this is the first bounce, this is the first bounce, this is the second bounce, this is the third bounce, right? So we need the height here after 3 bounces, right? To get that velocity, a hint is given. 25 is reduced, right? Speed is reduced by 25% each time, which means only 75% remains. Now after the first bounce, velocity of the ball when it comes up, this one velocity has to be let me write like this. It should be 75% of that initial value, right? From V, it should be 75%, right? This cancels. See, this cancels, which means this is 3V over 4, right? Now that velocity will be same until it hits again. So after hitting again, here, this will be lost by another 25%. So again 75% remains. Now you can see 304 again. This is 304 squared V. Now with that velocity it goes up and comes down, and after losing another 25%, this velocity has to be, now you can see the pattern, 304 cube V, right? Now if you need the height, If you need the height, now you can apply v squared equals u squared plus 2as again. V squared is 0 and u squared is here. U squared is this one, and it has to be 3 over 4 cube v whole thing squared minus 2gh, right? Take it to here, 2gh equals, this is 3 over 4, 2 and 3 and 6, 6. And v squared is here, v squared is 2g. 2g cancels. So h equals 3 over 4 to the power 6 meters. 3 over 4 to the power 6 meters, answer 4. For 31, answer 4. Answer 4. 31, answer 4. Answer 4. Right? That's a good question. Good question in the sense now you have to understand the question properly and then apply the equation with respect to the given data here. Okay, 32. Okay, part of an orbiting satellite is coated with a metal that has work function of 5 electron volts. Okay, let's see. 32. Part of an orbiting satellite is coated with a metal that has a work function of 5 electron volts. The Planck constant is 4.1 times 10 to the minus 15 electron volts. And the speed of light is 3 times 10 to the 8. What could be the longest wavelength of incident sunlight that can eject an electron from the metal coating? That can eject an electron. That is about photoelectric effect. So you know, in photoelectric effect, work function phi can be written as hc over lambda naught. Lambda naught is the threshold wavelength. Threshold wavelength is the maximum wavelength, right? Threshold wavelength is the maximum wavelength. So at once we can use this in this equation. Phi is given work function. Work function is 5 electron volts. 5 given electron volts. 4.1 times 10 to the minus 15. 4.1 times 10 to the minus 15. C is 3 times 10 to the 8 over lambda naught. Okay, this is a simplification now. Lambda naught equals 4.1 times 3 times 10 to the minus 7 over 5. So just simplify this number. 4.1 times 3 kilogram, 12.3. 12.3 over 5. 12.3 over 5. That can be simplified easily. Now the number is 12.3 over 5. So I can make this 10 by multiplying both by 2. So this becomes 24.6 over 10. Yeah. See, which means the value comes is 24.6. So it has to be 246. Has to be 246. Right? 32, answer 2. 32, answer 2. So likewise, be smart when you simplify in MCQ paper. So you can do these tricks. You can follow these tricks in MCQ paper. 33. A standard photographic slide has a picture size of 30 millimeters into 40 millimeters. An enlarged image of the slide is projected onto a screen 4 meters away. 4 meters away. The projection lens of a single lens slide projector. Right. Something like this. Now from the lens, the screen is 4 meters away. This is the screen. The screen is 4 meters away. If the size of the image on the screen is 1.2 times 1.6, what should be the focal length of the projector lens? Okay. Now from that I can get the magnification. See, magnification is gettable. So we know magnification is Image distance over object distance. So image height over object height. Now heights are given. So I'll go with height. Right? Height or width, anything you can use. You can use either height or width or anything. 1.6 meters. 1.6 over 40 millimeters. 40 10 to the power minus 3. Simplify this. 1400 over 40, which means 40 times. 40 times magnified. Now, considering this, you can apply lens formula. Sign convention is minus along the direction of light, and opposite to light, that is plus. So equation is 1 over v minus 1 over u equals 1 over f. 1 over f. V is minus, u is plus, plus and minus is still minus, and this is a convex lens, right? That is not given. You have to decide it. You have decided because an enlarged image is taken to a screen, right? Concave lenses can't form real images, right? They only have virtual images, right? Now these are real image, so therefore that's a convex lens. That's a convex lens. So therefore this is minus, right? I'll be multiplying the entire equation with minus. So 1 over v plus 1 over u equals 1 over f, and going to multiply the entire equation by v. By v. Since v is known, we can multiply the entire equation by v. Since v is known, right? So which means here 1 plus v over u. V over u is magnification again. V over u is magnification again. V over u equals v over f, right? Then I'll be writing here. Then 1 plus v over u is magnification. See, v over u is magnification again. This is again magnification. That is 40. Magnification is 40 now, known. And v is 4. It is given over f. So f is 4 over 41. 4 over 41 meters. 4 over 41 meters. And this is 400 over 41 centimeters. That's a simplification. Simplification. 400 over 41. What's the value? 400 over 41. 9.756. 9.75. So it is rounded. The rounded answer is given 9.75. So it is given as 9.8. That is given as 9.8. Answer 2. For 33, answer 2. Answer 2. $34. A test tube is made to float upright in a fluid by placing a metal ball at the bottom of the tube as shown in the figure. Total mass of the tube and ball is m. Density of the fluid is rho. And the cross-sectional area of the tube is A. Effect of surface tension and the viscosity of the fluid can be neglected. Right. If the tube is given a small vertical displacement, what is the period of oscillation of subsequent motion of the tube? Right. So this is a simple harmonic motion in hydrostatics. 34. See, a good one. Right. Good one. Okay. Now, so we know to prove simple harmonic motion, we are using F equals ma away from center. So therefore, we can use it as F equals minus ma, right? And this is the external force, or the external unbalanced force, which causes simple harmonic motion. Now, if a displacement is given due to that change of volume delta V, there will be an additional upthrust created. So that is the upthrust. That additional upthrust is the upthrust which created simple harmonic motion here, right? Which creates simple harmonic motion here. So therefore, F is due to an additional upthrust, that is delta V rho G. Delta V rho G equals ma minus ma, right? So delta V can be written as A times x. So let's say now this was taken additional x distance below, x distance down, right? Which means that volume can be written as Ax, right? that is ax rho g equals minus ma. Subject A is minus a rho g over m times x, right? So this can be written as minus a rho g over m square root squared x. So this equation follows a equals minus omega squared x, the general equation of a simple harmonic motion, which means omega of the motion, therefore omega of the motion is this, omega is a rho g over m, a rho g over m. So we know t can be written as, period can be written as 2 phi over omega, 2 phi over omega. So that is 2 phi root over omega again upside down m over a rho g, 2 phi m over a rho g, answer 2 for 34, answer 2. Answer 2. Next. 35. Consider a massless balloon attached to one of the end of the string. The other end of the string is attached to the bottom of the water tank, which is fixed in a truck, as shown in the figure. The balloon is completely submerged in water. The velocity time graph shown in the motion of the truck. All right. The positions of the balloon and the string inside the water tank during the time intervals T1, T2, and T3 are best represented by. Right. Simply, the idea is like this, right? When the parent object moves to a particular direction, the acceleration on the sister objects, sub-objects, are to the opposite. If density is greater than the density of the air medium, right? Now in this case, what happens is something like this. I'll explain using one scenario. See, I'll explain using one scenario. Now in the first part, it accelerates, right? So in the first part, it accelerates. So therefore, when this lorry accelerates in this direction to this direction, right? When this lorry accelerates to this direction, what happens is, now here we have some water. And this is the balloon with less density. So that is why the string is stretched, because the density of the balloon is less. That is why the string is stretched, because balloon tends to go upwards, right? So therefore, when this goes to right, when this accelerates to right, water here accelerates to left. So therefore, the one with the less density again accelerates to the opposite direction when water accelerates backwards, right? Water backwards accelerate with the automatically balloon forward accelerate venom, right? Forward angle venom, right? When water accelerates backwards, balloon tends forward, it accelerates forward. So that is what happens. So therefore, direction of acceleration of balloon and this lorry in this case is same now, right? So therefore, when it accelerates, it should be like this. If this acceleration happens, this is how it will be. So like this. And uniform velocity means that's uniform. And deceleration means that's the opposite acceleration. Deceleration in the forward direction is backward acceleration. Then it should be bent backwards. Answer is answer 4. Answer 4. 35. Answer 4. Right. That's a good question. Is with the thinking. Good question with the thinking. Right. So there are things to you to think. Right. Those are the arguments. So you have to build up your own arguments. 36. Consider 4 metal balls of same volume placed on a smooth horizontal surface. Mass of each, the first 3 balls are m, while the mass of the 4th ball is 2m. They are equally separated on a straight line. The first ball moves with a speed v and collides with the second ball, resulting in a series of linear elastic collisions. Elastic, very important. Elastic means no energy loss due to collision. Okay, resulting, okay, after all collisions, the motion of each ball is best represented by, okay. So one thing you have to know is this is a theory we are proving in collisions, right? If two identical balls hit elastically, like this, if two identical balls hit elastically when one is at rest and one is moving, what happens is, right? Let's say A and B, right? The one who had the velocity before comes to the rest after this collision. The one who had the velocity before comes to the rest, and the one who collides travels with the same velocity of the previous object, right? So this is a proved thing in collisions, for elastic collisions, right? This is only valid for identical objects. This is only valid for identical objects, identical elastic collisions, right? This is what happens. So therefore, when that travels with V, right, the last ball with mass M also travels with V, right? Now I'm going to consider that last collision, the final collision. I'm going to consider the final collision. Then in that final collision, this M travels with V and 2M is at rest, right? And after the collision, let's say M travels backwards with X and let's say 2M travels forward with Y, right? Now first if we apply linear momentum, this direction, mv equals minus mx plus 2my linear momentum. M cancels, which means v equals 2y minus x. I'll take it as equation 1. And then we can apply law of conservation of kinetic energy. Half m v squared equals half m x squared plus half 2m y squared. Half to half cancels. Half to half cancels. M to M cancels. Right? M to M cancels, not 2. M to M cancels. Right. So what remains is v squared equals x squared plus 2y squared. Right. Now I'm going to substitute this x from here. X can be written as 2y minus v. Correct? X can be written as 2y minus v. X is 2y minus v. So this can be substituted as v squared equals x is 2y minus v whole thing squared plus 2y squared. Simplify this, v squared 2y can 4y squared minus 4vy plus v squared plus 2y squared, right? V squared to v squared cancels. Take this to the other side, which means 4vy equals 6y squared. Y to y cancels. So which means y equals 4v over 6 is 2v over 3. Y equals 2v over 3. Right? So there's only one answer with 2v over 3. There's only one answer with 2v over 3. Right? Then it has to be the fourth one. So we can determine the other velocity as well if needed by plugging it here. From 1 v equals 2y again, then 2 times 2v over 3 minus x. 4v over 3. So that is 4v over 3 minus v. X kyanne 4v over 3 minus v. V is 3v over 3. So x is v over 3. Right? So answer is 4. Right? Velocity of the 2m is 2v over 3 and the last mass here comes backwards and again it does elastic collisions. Then velocity will be same of the last mass as well. Right? V over 3. So answer 4. 36 answer 4. This is a good question. 37. For optimum operation of a light emitting diode LED, forward voltage and current should be 2 volts and 10 milliamperes respectively. Transistor is having VDE 0.7 volts, current gain beta 100 and VC is at 0.1. for the circuit shown in the figure, what are the values of RB and RC for the optimum operation of LED? Right. To determine RB, okay. First of all, we can get IC. We know IC, so which means we can get IB. Because if the current flows through LED is 10 milliamperes, IC of the transistor is 10 milliamperes. Right? IC is 10 milliamperes. Question 37. Question 37. IC is 10 milliamperes. IC equals 10 milliamperes. So we know IC equals beta IB. Right? IC 10. 10 to the power minus 3. Beta is given 100 times IB. Simplify this. IB will be 10 to the power minus 4 amperes. Right? Now, I can determine potential at the other end of RB using potential divider for 3.3 kilo ohms and 1.7 kilo ohms. See, using potential divider, right? So we know this is connected between, here we have 5 volts plus 5 volts, and this is grounded. 3.3, this is 1.7, right? Now I need the potential here because RB is connected to this point, right? So if I need that, let's say V, that V can be written as V minus 0 equals potential divider 5 minus 0 over addition of resistors 3.3 plus 1.7 times, if I need the potential across this, into 1.7, right? So simplify this. This gives 1.7 volts. 1.7 volts. If that is known, we can write the cross line. For the transistor. Cross line comes from here to here, right? So this end is at 1.7, and after the transistor, this is grounded again. So which means is 1.7 minus 0 equals through IB, through RB, IB RB plus VB, right? So 1.7 equals IB is here 10 to the power minus 4, RB plus VB is 0.7, right? VB is 0.7. Simplify this. So 1.7 minus 0.7 is 1, which means 10 to the power 4. 10 to the power 4 ohms can 10 kilo ohms. So RB is found. RB is 10 kilo ohms. And other than that, we need RC. Right. So if you need RC, I'll do it here. If you need RC, so we know this is at 5 volts and RC is connected and the LED is connected. Right? And this is given, VC is 0.1, it is given. And this is also grounded. Right? So which means this is 0. If there is 0, this voltage has to be 0.1. Right? And across the LED, we have 2 volts. Across the LED, we have 2 volts. Across the LED, 2 volts. 2 volts. Right? So which means this has to be 2.1 volts. Then potential difference across this resistor is 5 minus 2.1, 2.9 volts. 2.9 volts. Considering that, apply V equals IR. 2.9, and I is here 10 milliamperes, 10 times 10 to the minus 3, RC. Simplify this. RC is 290 ohms. Right? So 10 and 290. 10 kilo ohms and 290 ohms. 10 kilo ohms and 290 ohms. 5. So 37, answer 5. 37, answer 5. A piece of metal is attached to the top rectangular wooden block that floats in water, as shown in the figure. 50% of the volume of the wooden block is submerged in water. The metal piece and the wooden block have the same mass. If the wooden block with the metal piece is flipped upside down, what could be the percentage of the volume of the wooden block submerged in water? Right. Now, currently 50% is submerged. Right. Currently, at present 50% is submerged. Right. 50% is submerged. So this is 50%. 50% is submerged. And this volume is enough to, this is a 50%, and this is enough to balance the upthrust, balance the weight by the upthrust. Correct? This is floating. So upthrust and weight are balanced. Right? Upthrust and weight are balanced. So this 50% is enough to balance upthrust. And this is the volume required. When this is upside down, what happens is, when this is upside down, there will be a small amount fulfilled by the volume here. Right? Now, initially, total 50% will be represented by this. But now, a small volume is represented by this coin as well. So, therefore, total will be 50%. Total will be this same volume, not the 50%. Total will be same V. But now, this represents V1 and this represents something like V2. But V1 plus V2 equals V again. V1 plus V2 equals this same V again. Right? So, therefore, since this part is replaced by another volume, a small volume, then V2 should be slightly less than this V. V2 should be slightly less than this V. Right? So, therefore, it is slightly smaller than 50%. For 38, answer 1. A simple argument. A simple argument. 39. As shown in the figure, an incompressible liquid flows steadily through the horizontal pipe. Two narrow vertical tubes are fixed at two places on the horizontal pipe where the cross-sectional areas are A and 2A. If the height difference of the liquid column in the two vertical tubes is H, flow rate of liquid through the pipe is flow rate. Flow rate is the product AV. Right? Flow rate. 39. Right? Flow rate. Flow rate is V over T. So that is the product AV. Product AV. Right? So I need the velocity. Since I need velocity, now I need to use fluid dynamics, Bernoulli's equation. Bernoulli's equation. Right? So I'm going to use Bernoulli's equation by considering 2 points on this tube like this. By considering 2 points on this tube like this. Let's say 1 point is here and another point is here. A and B, let's say A and B. Now, we are going to use Bernoulli's theorem now. And about areas are given. Since areas are given, so before using Bernoulli, we can get this relationship using continuity equation. You can get this relationship using continuity equation. We know A1V1 equals A2V2. A1V1 equals A2V2. So therefore, A1 is A now. Right. So let's assume velocity of here is V1 and velocity here as V2. Right. Then A V1 equals 2A V2. Right. A to A cancels, which means V1 equals 2V2. This is a relationship we have. V1 equals 2V2. Right. And then if I use Bernoulli, right, for these two, now when the height difference higher speed means you have to know these things. Right? Higher speed relationship in fluid dynamics, area, pressure, and velocity are in a relationship like this in fluid dynamics. Right? Higher the velocity, lesser the pressure, lesser the area. Right? So lesser area means higher velocity. Higher velocity means less pressure. So less pressure here, which means this height is less, and high pressure here. This height should be somewhat higher, greater than this. And this difference is given as H. This difference is given as H. Right? That is given as H. Okay. Now, if I use Bernoulli here, Bernoulli's theorem, PA plus half rho V1 squared equals PV plus half rho V2 squared. Right? So about PA and PB, we can write another equation from this. See, we can write another equation from this, starting from here. This is at atmospheric pressure. Starting from that point, let's assume this height from here to here as what, x kilogram, right? Then P naught coming down plus x rho g, same horizontal level. See, let's write AB. Let's write pressures at A and B at once. See, PA can be written as P naught plus x rho g, right? And PB can be written as P naught plus h plus x rho g, right? Now you can substitute that here. You can plug that here, right? So let me plug this way: PA minus PB. PA minus PB equals half rho can be taken out. V1 squared minus V2 squared, right? Now from here, PA is P naught plus x rho g. PB is P naught plus x rho g. Substitute here, P naught to P naught cancels, x rho g to x rho g cancels. Only h rho g remains. Half rho for V1. For V1 we can use 2V2. For V1 we can use 2V2. So that is 4V2 squared minus V2 squared. Rho to rho cancels. Here 2GH. 2GH equals, this is 3V2 squared, which means V2 equals 2GH over 3 whole thing root. Right? So we know flow rate is AV. Right? Now since V2 is known, I'm going to use flow rate to this tube, this part of the tube. So flow rate is A is 2A there, and velocity is V2, this one, 2GH over 3. So that should be 2A times 2GH over 3. 2A times 2GH over 3, answer 5. For 39, answer 5. Answer 5. Right? Body. The figure shows the displacement time graph for the motion of two cars with respect to a lamp post aside the road. Consider the displacement to the right side of the lamp post as positive. Okay. Now that is measured from a lamp post. Right. So let's say the lamp post is somewhere here, and displacements to the right are positive, which means to the left from that post are minus. Right. The student has made the following statements regarding the motion of cars relevant to the points P given are marked on the graph. Right. Displacement time graphs are given. Right. Relevant to P, car 1 left crosses car 2 at point P. At point P, what has happened is car 1's displacement is 0. And that is coming from the negative side. So which means car 1 coming from here. Car 1 is coming from here. This is car 1 is coming from here, and at P it has reached the post. Because displacement is 0. But yet at the same time, car 2 is still at the positive displacement, which means that is at the right side, and that is coming towards the post from the right side. So which means car 2 is coming like this. Statement A is wrong. Because car 2 is not reach the post, because car 2 is at the right of post. Car 2 is at the right of post. B. Relevant to Q. Both cars are moving towards the lamp. Relevant to Q. At Q, car 1 is positive. At Q, car 1 is positive, which means car 1 has already passed this. Car 1 has already passed this. Because after 0, after the point 0, car 1 is now at the positive side of displacement. Positive side, which means that is at the right side and it's moving to the right. So that is moving away. So it says moving towards it. No. Car 1 is moving away. Car 1 is moving away. That is also wrong because car 1 moves away. C. Relevant to R, car 2 coming from right passes the lamp post. R car 2 coming from right. That is correct. Coming from right passes the post. Yes, correct. Only C. C is correct. Only C. Only C. For 40, answer 2. 40, answer 2. For 40, answer 2. $41. $41. A whistling firecracker having a constant whistling frequency is fired vertically upwards. It travels initially with an acceleration, then with a deceleration. Right? Initially acceleration and then deceleration. Okay, 41. So initially this travels with an acceleration, right? Initially acceleration, right? And then a deceleration. Deceleration means that's a opposite acceleration, right? Something like this. And finally blast before coming to the rest. An observer at ground directly below the firecracker listens to the whistling sound of the firecracker. Consider the following statements regarding the frequency of sound heard by the observer. Doppler's effect. The question is from Doppler's effect. Alright. Question is from Doppler's effect. During the acceleration, it is higher than the whistling frequency and the decreasing with time. Now, during acceleration means now observer is somewhere here. Observer is somewhere here. Observer is somewhere here. Right? So, velocity of the firecracker is away from the observer. Velocity is away. Right? So, if velocity is away, statement A, if velocity is away, frequency decreases. So, therefore, during the acceleration, higher than whistling frequency, that is actually lower than whistling frequency. Right? Because velocity is away. V is away. So, frequency decreases. A is wrong. During the deceleration, it's lower than the whistling frequency and increasing with time. During the deceleration. Now, still the velocity is, even though it is decelerating, direction of velocity is upwards. Direction of velocity is upwards. Since velocity is away, that is less. Correct. That part is correct. And it increases because it's finally going to be at rest. Finally, it is going to be at rest. Finally going to be at rest. So at rest, it will hear the actual frequency. At rest, it will hear the actual frequency. Which means now this is a less frequency than actual frequency. Then from less frequency to actual frequency, it increases. Increasing with time, that is correct. Increasing with time, that is correct. So B is correct. C. Just before the blast, it becomes equal to the whistling frequency. Yes. Just before the blast, it becomes equal to the whistling frequency. I told you. Because when there's no velocity, no Doppler's effect, so the actual frequency will be heard. If there's no velocity. So that is also correct. B and C. B and C. 5. So 41, answer 5. For 41, answer 5. $42. Wait. It says blast before coming to rest. Oh, sorry. Just before the blast, it becomes equal. No. It blasts before coming to rest. So if it is blasting before coming to rest, then this point is not reached. It blasted. It blasted. So which means this is wrong. This is wrong. Again, only B. Only B. Answer 2. For 41, answer 2. For 41, answer 2. Right? So before coming to the rest, it's clear. Before coming to the resting point, it blasts. So that frequency cannot be heard. 42. A metal ball of mass 700 grams contains 1 liter of water at 27 degrees Celsius. When a steel ball of mass 300 grams at 120 degrees Celsius is dropped into the water, in the bowl, the final temperature of water is measured to be 30. Specific heat capacities of steel and water are 500 and 42,000, 400, 2,000 respectively. Out of the metals given in the table, what could be the metal that the bowl is made of? Okay. Now, what happens here is heat absorbed by container plus water with the heat loss, right? Heat loss equals heat emits by steel balls, that is, yeah, steel balls. Heat emits by steel ball, right? This is the emission by balls, right? So considering that, I'm going to write this equation. See, considering that, we can write this equation. Considering that, we can write the equation. Heat absorbed by container and water, right? Mass of the container is given 700. Okay, then see 700 over 1000, that is in grams, right? So let's say that is S. Theta should be, that is initially at 27. So that is just 3 plus water. 1 liter of water. 1 liter is 1 kilogram. 1 liter is 1 kilogram. So 4,000 times 3 plus this heat loss. Let's say delta Q. Heat loss is delta Q, right? And on the other side, mass of the ball is 300. 300 over 1000 and 500 times 90. Temperature difference is 90. All right, simplify this. We can simplify this. What's the value? Make a 0.7. This is 2.1 S. This is 2.1 S. Right? And this is 12,600 plus delta Q equals this is 2, 3 cancels, right? 5 times 150 times 9 again 13,500. 13,500. So which means, see, 2.1 S equals 13,500 minus this scale again 900. 900 minus delta Q, right? So S should be 900 over 2.1 minus delta Q over 2.1. So we can check this value. 900 over 2.1. $428. මෙන්න මේ part එක විතරක් එනවා. This part is 428. Now minus something. So which means S should be something less than 428. It should be something a bit less than, because this is due to the heat loss. Heat loss is a small amount. So it should be a little bit less than 428. Only answer less than 428 is right. Only answer in the sense the only answer which is a bit less than 428 is 385, right? Which means it has to be copper. 42 answer 2, right? So which means SC is minus this part. My answer is this: SC is less than 428, a little bit less. So therefore, it has to be 385. Therefore, that is copper. Right? Question with a little bit of a thinking with a small difference. Right? 43. Three right angle prisms. Okay. Three right angle prisms of refractive indices N1, N2, and N3. N2 greater than N1 and N2. N2 is the greatest again. N2 greater than N1 and N3 are arranged very close to each other on a table as shown in the figure. There are no gaps between the contact surfaces of the prisms. A ray entering through the face AB with an incident angle I refracts at surface AB, BC, and CD and DE. Okay. And emerges from the face D without deviation. Which means it travels back, it emerges from the prism setup with the same angle it came in. Right? Now, if I draw the ray diagram, it should be something like this. Now it comes here, I with angle I. Right? This is ray arc density towards the angle. So it's towards the normal, it bends like this towards the normal. So let's say this is R, right? And here again, there will be another refraction. N2 is greatest. So therefore, this is again from, this is ray to dense. So it bent towards and goes somewhere here. And here again, from dense to rare. So it goes away. And here finally, from dense to rare again, like this, and this angle has to be same. If there is no deviation, that has to be same. Right? If I extend this, the angle between these two is I, which means this is I in a method. This is I. And this is 90 minus I. Something like that. So you have to identify these angles. Then, what's the question? Which of the following expressions is correct? Okay. R1, R2, R3 are given. R1, R2, R3 are given. The angles of refraction at surfaces AB, BC, and CD. AB, R1. Then this is R1. Angles of refraction, this is R2. Right? And this is R3. Right? And all of these angles are right angles. All these angles are right angles. Because they are right angle prisms. Okay. Now, let's use this for first refraction first. Right? Let's use the equation for first refraction first. Right? First refraction, we know Snell's equation N1 sin I equals N2 sin R. N1 sin I equals N2 sin R. Right? Then N1 is 1 sin I equals N2. N2 here N1 now. Sin R is sin R1. So one answer here, sin I equals N1 sin R1. So we'll keep it and simplify because we are asked about a relationship between incorrect one is asked. So this one is sin I equals N1 sin R1. Sin I equals N1 sin R1. So 1 is correct. Hari, abhi मैं टिक दागा 1 2 3 4 5 see 1 is correct. 1 is coming. So these are the statements we are going to check. 1 2 3 4 5. Now 1 is correct. The result is here. Second one N2 and N1. So we will use this equation for let me label the surfaces. This is for AB, yeah. So I use this for AB, surface AB. Now I'm going to use for surface BC. Now in this case I'm going to use for surface BC, this one, BC, right? Then again, same equation. Now this is N1, N2 and N3, right? N1 sin I is sin, this is 90 minus R1. This is sin 90 minus R1, right? Equals N2 sin R2. So you all know that sin 90 minus angles are cos angles. So therefore, this can be written as N1 cos R1 equals N2 sin R2. N1 cos R1, N2 sin R2 is also there in the second one. So second statement is correct, right? Third one, sin I equals N3 cos R3, right? To get that, we can use the equation here, right? We can use the equation here. N3 and I, anyway, surface. What is surface? DE. See, now I'm going to use it for surface DE. Then N1 is N3, and this angle here is 90 minus R3, right? So this is sin 90 minus R3 equals AR, refractive index is 1, and this is the angle of refraction, that is sin 90 minus I. Right? This is sin 90 minus I. This angle is 90 minus I. This angle is 90 minus I. Right? So which means this is N3 sin 90 minus R3 and cos R3. And this is sin 90 minus I and cos I. Right? N3 cos R3 equals sin I is given. So it is coming as cos I, which means it is wrong. Which means third one is wrong. Then 3 is incorrect. Cos I equals N3 cos R3. Cos I equals N3 cos R3. It's there. So 5 is correct. 5 right? And if you need to get the fourth one can be taken if you use it for N2 and N3. The relationship is between N2 and N3 for this surface CD, right? Now answer is not. Now if needed, you can apply to CD and get 4 as well. Correct? Answer is 3. For 43, answer 3. For 43, answer 3. (44) Each of the single turn wire loops placed on XY plane as shown in figures carries the same current I. A uniform magnetic field is applied along the positive direction of x-axis. Assume that each wire loop can rotate freely about its symmetric axis perpendicular to the magnetic field. Which choice represents the order of loops that the initial torque acting on them are in descending order, right? So they are in a perpendicular magnetic field applied along the positive direction. Oh, they are applied along the positive direction of x-axis. Assume that each wire loop is can be rotated freely. Okay, right. So we know from magnetic fields, force moment on a loop in a magnetic field. Force moment in a loop in a magnetic field can be written as G equals BINA. G equals B now. G equals BINA. So G is a force moment. Force moment is a torque. That is a torque. So that depends on B, I, N, A. Now B is constant for all. I is also same. N is also same, which means for this scenario, it depends only on area. It depends only on area. So what you need to do is calculate these areas. Higher the area, higher torque. Higher the area, higher torque. Calculate that area. Higher the area, higher the torque. Right? PQRS. Okay, let's see these areas. P, Q, R, S. P. Now that is why values are given. Now you can see the values are given in the axis, right? That is for you to calculate. For you to calculate area, right? For P, that is half times 2 times 4, half times 2 times 4, which means area is 4. For Q, area is 1 times 1, 2, 3, 4, 5, 4, ne? 1 times 4, that is also 4. 1, 2, 3, 4. 1 times 4, ne? Make it 3 the. Yeah, 1 to 4, it's 3, ne? Yeah, thanks. 1 to 4, it's 3. Right? So which means this is 3 here. Yeah. And R, area is 5R squared, ne? Right? 5 is 3.14. And R squared is 1 there. So 1 squared. Right? Right? R is 1, ne? R is 1.5, ne? 1 to 4, 3. R is 1.5. So that is 1.5 squared. 1.5 squared. Again, 3 over 2 whole thing squared. Right? Which means this is a 9 over 4. Ne? This is 9 over 4. 3.14 times 9 over 4. So I need a rough value. What's the value? 7 point something. This is 7. S is 1 to 2.5 again, 1.5 and 1.5. Ne? Yeah, 1.5 and 1.5. So that is 1.5 times 1.5. Again, 2.25. 2.25. Right, that's it. Then higher the area, higher the torque. Highest area is with R. Ne? So the order is R, then second highest Q, then P, S. R, Q, P, S. R, Q, P, S, answer 2. For 44, answer 2. Right, 45. Three cells with electromotive force EMF E1, E2, and E3 and internal resistance R1, R2, and R3 respectively are connected as shown in the figure. Which of the following expressions gives the potential at point P of the circuit? Right. Okay. Right. Let's write this way. We need potential at point P. Okay. If I start writing potentials starting from one of the grounded point. The points are grounded, right? Yeah, easy. One of the grounded points, let's say through E1, I'm going to write the potential. Then 0 plus E1, because we are going through E1 from negative to positive, right? So that is plus E1. And to the same direction of current, which means minus IR, then minus I1, R1. Currents are, let's assume the currents as I1, I2 and I3. Let me draw the diagram, otherwise you will get confused. Diagram is here. See. E1, E2 here, and E3 here, right? And R1, R2, R3, R1, R2, R3. This is grounded, right? Which means potential at any of these points are 0, right? Now I'll mark these currents as I2, I3, and I1, right? Now I'm going to write this potential starting from here, right? 0 plus E1 to the same direction of arrow of the battery from minus to plus, plus E1, and through this resistor to the same direction of current, that is minus IR. So I1 R1 equals VP, potential at P, right? So which means from here I can get I1. See, what is I1 now? Subject I1, it will be E1 minus VP equals I1 R1. So I1 is E1 minus VP over R1, right? So similarly, I can deduce other currents as well. Similarly, we can deduce other currents. See? Similarly, we can deduce other currents like this. I2 will be E2 minus VP over R2. And similarly, I3 will be E3 minus VP over R3. Right? Right. Now, if that comes to the same point, I1, I2, I3, if it comes to the same point, according to Kirchhoff's first law, you know Kirchhoff's first law, according to Kirchhoff's first law, the currents has to be same, has to be 0. Not same actually, 0, because all three are coming to the same junction. All three are coming to the same junction. Total current inflow equals total current outflow. Now there is no current outflow there. So which means that has to be 0. If I consider P, see, using Kirchhoff's first law, using Kirchhoff's first law, total current inflow equals total current inflow equals total current outflow. Total current inflow equals total current outflow, right? Total current inflow is I1 plus I2 plus I3, I1 plus I2 plus I3. Total current outflow is 0, right? Now I'm going to simplify this by plugging these values. Then VP will be the only unknown variable here. So after plugging values, we can simplify. So let's see how it can be simplified. I1 is E1 minus VP over R1, and I2 is E1 minus E2 minus VP over R2, and I3 is E3 minus VP over R3 equals 0, right? Now I'm going to multiply the entire equation with R1, R2, R3, right? That will be easy. Otherwise, without taking common denominators, otherwise the other option is taking common denominator. Now without taking common denominators, I'm going to multiply the entire equation with R1, R2, R3, right? So hereafter, multiplying this equation with R1, R2, R3. Multiplying the equation with R1, R2, R3, right? See what happens when it is multiplied with R1, R2, R3 remains. So which means R2, R3 times E1 minus Vp. And from here, R1, R3 remains, it times E2 minus Vp, right? And from here, R1, R2 remains, E3 minus Vp equals 0. Now we have to multiply the brackets. Multiply the brackets, right? We have to multiply brackets. See, from here, R2, R3, E1 comes, right? To take all VPs to the other side at once. See? Now here, R2, R3 minus VP comes. Again, minus R1, R2 VP. And from here, minus R1, R3 VP. And from here, minus R1, R2 VP. So I'm going to take them all to the other side, right? I'm going to take them all to the other side at once. Which means this can be taken to the other side as R2, R3 VP. And this can be taken to the other side as R1, R3 VP. And this as R1, R2 VP. And here, what remains is plus R1, R3, E3 remains, right? And here, R1, R2, E3 remains, E2. Okay. VP can be taken out because we are in the process of subjecting VP, right? So VP can be taken out. And nothing is common here. No, nothing is common here. Which means we can take VP out only. That's it. Then this is R2, R3, E1 plus R1, R3, E2 plus R1, R2, E3. And if VP is out, R2, R3 plus R1, R3 plus R1, R2. So divide this and subject VP. E1, R2, R3. 5, ne? 5. So 45. 4, ne? 4. R2, R3 plus R1, R3 plus R1, R2. Yeah. Answer 4. 45. Answer 4. That's a very good question. Very good in the sense. You have a good simplification, a good application of the question. Right? Take it down. Take it down. A good one. That's a good one. Now, when we are moving towards the last 10 questions, you can see the clear difference. You can see a clear difference, right? So when we move towards last 10, now usually last 10 questions are kind of, right? That's not a rule. Usually with some different simplifications and maybe lengthier questions, decimal simplifications, those things are usually put as usually between 30 and 50, right? Last 10-20 questions will add the thing here product pay na thiyano, right? So it takes this whole thing to simplify. Take it down. Can you explain 24th question again? 24. 24. 24. 24. Oh. Now it says currents are flowed in both cases, both scenarios. So which means diode and resistor should not be in a series combination because there is no current flow if a diode is reverse biased. So if they are in a series combination, when it is reverse, there shouldn't be a current flow, right? But now it says there are current flows in both cases, which means these two should be parallel, right? So that is what the circuit I draw by being parallel. And the other argument I used was when a diode is reverse bias, its resistance is maximum. And when the diode is forward bias, its resistance is minimum, right? So therefore, now higher the resistance, lower the current. Lower current is at the first scenario, 50 milliamperes, which means at first scenario, the diode should be reverse biased, right? And in the second scenario, that should be forward biased. So to satisfy that, I draw the circuit and connected batteries, right? Now clear, I asked before. Sorry about that, I didn't see that in the chat because I was not looking at the chat and just going through all the questions, right? Sorry about that. Okay, 46, ne? 46. This is a good question from Kirchhoff's laws. This is a good question from Kirchhoff's laws. This one, the one we just did, is a good one from Kirchhoff's laws. (46) Consider a battery of electromotive force EMF E naught and internal resistance R, as shown in the figure. It is connected in series with a resistor R and variable DC voltage source that can be reversible. DC voltage reversible. All right. Okay. When the voltage of the variable source VR is varied, the graph of I versus V is best represented by another graph. Right. Now we can see the potential difference is given across this part as V. 46. 46. Potential difference across this part of the circuit. Potential difference across this part of the circuit is given as V. Right? R. And this is E naught. E naught. Right. And the current flow is also marked. Now, so starting from somewhere here, we can write potentials again. Starting from somewhere here, let's say A to B, right? VA opposite to arrow of the battery minus Z naught, and same direction of current means minus IR. So that is minus IR equals, now we add VB. Now we add VB. What we know, VA minus VB is given as V, right? VA minus VB is given as V. Then this can be written as VA minus VB equals, if I take this to the other side, that is E naught plus IR. VA minus VB is V, that is given. And we need to plot the graph with I. Okay. E naught plus IR. Right. Now I will subject I from this graph, from this equation, to make it to plot the graph. Right. Modify it. IR equals V minus E naught. IR equals V minus E naught. We need I on y-axis. So I equals, this can be written as 1 over R V minus, this is 1 over R on E naught over R. Right. Now identify these terms, identify the graph. V is at X, and this has to be the gradient, and this has to be intercept, and this is Y. Mx minus C. Y equals Mx minus C. Mx minus C again 4. That's a standard curve. Mx minus C for 46, answer 4. For 46, answer 4. That's a standard curve. Another graph question, another graph plotting. For 46, answer 4. That's a standard curve. Right? 47. Consider the circuit shown in the figure. The graphs show the waveforms of the applied voltage and the current through load L. right? The average power dissipation of the load is, right? The theory of this part is this. We have something called RMS values in current electricity, right? The RMS values are, if we have a variation, an alternative variation like plus minus, when we have an alternative variation like plus minus, right? The equivalent value, this is available for both V and I. Current potential, right? And that equivalent value is called the RMS value. That VRMS can be written as Vmax. This value is called Vmax. This value is called Vmax, right? This one, maximum value Vmax. So that can be written as Vmax over root 2. This is an equation we have, RMS values. When we have alternative currents, right? When we have alternative currents, RMS means root mean square value. Root mean square value means there is the equivalent amount of voltage or current from this alternative current, right? As we write VRMS, we can write IRMS as well, right? Now here, two alternative values are given, two alternative voltages are given. So I'm going to use it. Then from the first one, I can get VRMS from the first graph, right? See, this is the theory part. Huh? This is the theory part. This is the theory part. Okay, now from the first graph, I can get VRMS. Apply that equation. VRMS equals Vmax over root 2. Vmax in the given graph is Vm. So that should be Vm over root 2. Right? And from the second one, I'm going to get IRMS. IRMS, that is Imax over root 2. And it should be Im over root 2. It should be Im over root 2. But in the second graph, you can clearly see, for one half of the time interval, I is 0. For one half of the time interval, I is 0. And only one half I remains. For only one half I remains. Therefore, this is when there are non-zero values. Now, one half is 0. Then from this, it should be another half value. Right? So this is IRMS. Now, final IRMS is Im over 2 root 2. Right? So this half is due to I equals 0 in one half. I equals 0 in one half. Right? Now, if power dissipation is needed, very straightforward. P equals VI. P equals VI. So here you have to substitute RMS values. VRMS times IRMS. VRMS is Vm over root 2. IRMS is Im over 2 root 2. Simplify this. That is VMIM. That is VMIM over 4. VMIM over 4. Answer 2. For 47, answer 2. Right? $48. 47 is also a good question. 47 is also a good one. 48. Two long, straight and parallel wires are placed in free space. Consider the following two cases shown in the figures. Wires carry the same current in same direction and opposite direction. Right. Variation of the magnetic flux density B between two wires. Okay. First scenario is this. Same direction. Second scenario is this. Opposite directions. Right. So we know direction of magnetic flux density is given by right hand rule. Right. When this shows the direction of current, this gives the direction of magnetic field. Right. Now here, if I check the direction of magnetic field, see, if I check the direction of magnetic field on this side by this first wire is cross. By the first wire is cross. And direction of magnetic fields here by the second wire. You can see direction of magnetic field by the second wire is dot. So this is dot. They are vectors, huh? They are vectors. So therefore, when we consider, now what about the positive direction? Nothing is given. It's given. Consider the direction of magnetic flux density into the paper as positive. Then this is a positive value. And here negative. So which means this variation has to be plus and minus thing, right? This side is positive, this side is negative. So something like this. And for the next one, check directions again. This is cross positive. And from the other wire, there is downwards current. If you check this side, there is also positive. Which means there are no neutral points. Neutral in the sense there are no points which are having a zero magnetic field because both are adding up, and that is in the positive side. So which means it has to be something like this, right? What's the answer? 4, for 48. Answer 4. (49) equivalent resistance. What is the current through the battery of the circuit shown in the figure? Right. Current through the battery of the circuit. So which means if we can simplify the total equivalent resistance, we can apply V equals IR for the system. V equals IR or Kirchhoff's laws. Both are fine. Right. So therefore, my target is simplifying the equivalent here. Okay. So get here. My target is to simplify this. 49. My target is to simplify this. Okay. So look at here, I'll be erasing some resistors while simplifying, right? Okay. My target is simplifying this. Right. Right. 4R, 4R, 8R, 4, 4, 8. 1, R can 1, 1, 1, 2, 2, 1, 1, 1, 1, 2, 2, 8, 4, 4. Right. So first we can see these two are in a series combination. Same current flows through. If same current flows through resistors, they are in series combination. If they are connected between same points in the sense, same potential difference, they are in parallel combination, right? So that is how series and parallel combinations are identified. Now these two are in a series combination. Then 4 and 4 means, see, I'm going to simplify at once. Look at here, 4 and 4, 8. That 8 to this 8 will be parallel because connected between same points. Then 8 and 8 means they are parallel. 1/8 plus 1/8, that will be 2/8, which means 8/2, 1 over. So R is 8/2, that will be 4. 4 can 8, 8 can 4. So this can be replaced with a single 4. This can be replaced with a single 4 here. So this is simplified. This can be replaced with a single 4. Similarly, the same thing is here in the bottom, right? So which means this can be replaced with a single 4. Right. Now, this remaining circuit is symmetric, right? If a circuit is symmetric, if an equivalent resistance circuit is symmetric, right? First draw the symmetric line, and you can remove the joints which are on the symmetric line, because if that's a symmetric circuit, the logic is this, the argument is this, same current flows through corresponding branches. Now, if the current flow here is I, same current flows through the corresponding branch here. Therefore, this joint should be removed, right? To satisfy same current flows in corresponding branches, right? We are removing joints. So this joint can be removed like this. This joint can be removed. Now this can be simplified. See, now it's very easy. Now it's very easily simplifiable. 2 and 2 now they are in a series combination. 2 and 2, 4. 4 and 4 2. And 2 and 1 and 1 4 again. So which means that is simplified to 4. That is simplified to 4R. And here same current flows through these two as well. 1 and 1 2. 1 and 1 means 2 here. And from this side also 2 and 2 4, 4 and 4 2, 2 1 1 4. So here also we have another 4. Right? Now all three are in a parallel combination, which means 4 and 4 is 2. Right? We can simplify by mind. 4 and 4 2, and 2 and 2 is 1. So which means R here is resultant here is R. Resultant here is R. Then if I need the current, right? Use V equals IR. For system, V equals IR. V is given as V, we need I. Now the resistance is R, which means I is V over R. I is V over R, answer 4. 49, answer 4. That's also a good one. And this is a common question. Equivalent resistance is a common question. And there are around 9 types of equivalent resistance questions. Right? This is a symmetric circuit. One of the types, symmetric circuit. Symmetricness. $50. Okay. A small object is placed inside a right circular cone with axis vertical and vertex down as shown in the figure. The coefficient of static friction between the inner surface of the cone and object is mu. What is the maximum angular velocity of rotation of cone about its axis for the object to be on the inner surface? Object to be on the inner surface of the cone without slipping at a distance d away from the axis. Okay. Axis is here. Angles are given, theta. Object is here, d distance away. Distance d away. Right. So we know there will be a perpendicular reaction exerted on this by the plane R. And mg acts like this. Right? And if this is theta, you can find angles. This is 90. This is 90 minus theta. This angle is theta. Right? Now, since that's a circular motion, considering circular motion, other than that, friction is there. We have friction for the maximum. What's the maximum angular velocity? Maximum angular velocity. So at the maximum angular velocity, what happens is, at the maximum angular velocity, the tendency of this object is to move away from the center of the circle. Move away from the center of the circle. Right? So therefore, friction acts downwards. Therefore, friction acts downwards. That is very important. Right? That is very important. Determining the direction of friction. Right? At the maximum angular velocity, the tendency is to go away due to the centripetal force. Simply, the reason is centripetal force. Centripetal force act in the circular motion again, it tends to go away from the center. So therefore, friction will be towards the center. Right? Friction is towards the center. If it was the minimum angular velocity, the friction is opposite. Because at the minimum velocity, it tends to come down. So friction will be upwards. Now its maximum angular velocity, friction is downwards. Okay, now we can solve this. Now we can solve this. See, for any circular motion, you know what we do is, for any circular motion, applying F equals ma towards center, and since this is the horizontal circular motion, we can consider vertical equilibrium, right? Just two things. Okay, first I'll consider vertical equilibrium. Vertical equilibrium. Vertically upward forces equals vertical downward forces. Vertically upwards we have r sine theta. Vertical upwards are sine theta. Vertical downwards mg plus, if this is theta, this is 90 minus 0, this angle is theta again, plus f cos theta, right? R sin theta plus r sin theta equals mg plus f cos theta, and mu is given. So I'm going to expand this. This means r sin theta equals mg plus r is, f is mu r. So mu r cos theta, right? So we keep this as equation 1. Right? Then we can use x equals ma towards center. We need omega, right? F equals ma towards center. Right? Towards center, we have two forces. One is r cos theta, and the other one is f sin theta. Right? Equals ma, and we know a can be written as r omega squared. So r is d now, d omega square. Right. Now, again here also we can expand this as r cos theta. F is mu r again. Mu r sin theta equals md omega squared. Right. So here also I use the same equation, F equals mu r. We need omega, which means now if I plug the value of r here, this is done. If I plug the value of r here, this is done. So therefore, I'm going to get r from this. I'm going to get r from this. See, from 1. We can get r, subject r, that is sin theta minus mu cos theta equals mg, which means r equals mg over this thing, sin theta minus mu cos theta. Right? Now, I'm going to plug that r here. So I can take r out from this again. So that is cos theta plus mu sin theta equals md omega squared, right? Yeah, m cancels when we substitute that, right? So r is mg over that whole thing sin theta minus mu cos theta, right? Times here cos theta plus mu sin theta equals md omega squared, m to m cancels, right? D is in the answers, right? Now from here we can subject omega squared. Omega squared is g times cos theta plus mu sin theta. Cos theta plus mu sin theta over d times sin theta minus mu cos theta. Right? Now if we need omega, omega is the square root of this. Omega squared. This is omega squared. This is omega squared. So if you need omega, omega will be the square root of this. Then I can check the answer here. G times cos theta plus mu sin theta over d times sin theta minus mu cos theta. 4 again. 4. 3. 3. G times cos theta plus mu sin theta over d times sin theta minus mu cos theta. Answer 3. For 50, answer 3. Right? This is a good question. A very good one from circular motion. That is from circular motion. Right? A good one. Okay. Okay, so with that we have come to the end of the first part of 2019 annual paper, right? So MCQ is done. In another coming date, I'll be taking to discuss the second paper as well, right? Okay. So any questions? Any questions or anything to clarify from the things we discussed? Or is it clear? Is it clear enough? Students? All good? Why? Hungry? It's 11:30. Right. So then here I'll be wrapping up the session. So once the live video is ended, once this live stream is ended, so if you get this, if you got some advantage from this, if you understood this, please put a comment to this video once the live video is ended, because if you put that in the live chat, it will be disappeared after the live is gone, right? It will remain on YouTube if you put a comment once the video is ended, right? So therefore, I'm happy to see whether you have understood the questions or if it's clear to you and if you have taken any advantage from this, right? So therefore, if you stayed in the class during whole these 3.5 hours, yeah, during all 3.5 hours until now, so you can put a comment to the video once this is ended. All right then. So then that's it for part one. That's it for part one. Right. So I'll be winding up the session here. Let's meet with another discussion or with another free seminar, free with my channels and groups. Then you can get all updates through them. Right. Okay then. All right. Good night and goodbye. See you again.